Rhodium. This lesson is not about pigments. Rhodium is not present in any pigment. Rhodium is actually present here in the tube, in particular in our tube, the tube that we are using for this course. When you purchase a X-ray system, you order your tube and they will ask you what kind of target you want on your tube. So generally it's could be gold, could be silver, tungsten. Rhodium is one that we generally choose for our application in cultural heritage, in pigments identification, because basically the material of the target will always shows up in your spectra. So if you choose as a target gold and then you measure gold in your analysis, of course that is creating an interference. You always see the gold and something. So generally you want to have some material, some element that never shows up in your research, in your study. So rhodium is definitely not something that we will find in pigments analysis. So that was my choice, but it's a pretty normal general choice. This lesson about rhodium is important in order to interpret what are the peaks of rhodium that always shows up in our spectra, so that we don't wrongly interpret them as other elements. Rhodium, atomic number 45. So here we have the X-ray lines of rhodium. So we have K alpha 20.2, K beta 22.7, L alpha 2.7, L beta 2.8. For this lesson we are going to use two samples. This white plate is made of HDPE, high density polyethylene. So basically it's a plastic that is very dense and will reflect the X-ray coming from the tube over here. So we are using this plate to see what is the output of the X-ray tube. Then we are going to use a piece of rhodium that we have. So rhodium is very costly, so I just have this tiny bit, and these are the two measurements we are going to make. We are going to measure HDPE, so the high density polyethylene, and the rhodium sample using the three different filters set up for the X-ray tube. So we start with a no filter, so no filter at all on the tube. Then we test the low keV, so when we use this aluminum filter, and then the routine filter set when we use both these filters. There it is. This is the spectrum of the HDPE without any filter in the no filter setup, and then on top the red one is the spectrum of the piece of rhodium using the no filter setup. We see the peak of rhodium at 2.7. So in this case we are looking at the LA peaks. And then we see that the other peak, the L beta, is at 2.8, and it is over here. But the peak that we have in HDP, so the output of the tube, let's say, that we see in our spectra always, in this one at almost 3, this one is another thing. And also you see the shape, this one is much more intense. So this one, this peak is definitely not the L beta of rhodium. What it is argon. So here we have a combination. The first peak is the L alpha of rhodium, the second peak is the K alpha of argon. Let's now discuss the spectrum when we have the low keV filter setup. Let's start with the HDPE. the spectrum basically just from the tube. So what we see is that is pretty flat. Then here we have this large compton that is related to this peak over here, that this one is actually the K alpha of rhodium, is 20.2. Then rhodium has the other one, a K beta 22, so will be smaller and will be around here, but is much smaller. And indeed, this peak in the black compare with a big peak in the red, that is the peak of the actual piece of rhodium. So when we have a pure rhodium, we will see the K alpha over here, and then we have this one is the K beta of rhodium. This is the routine filter setup. So in this case, we see that the black spectrum of HDPE is smaller, so we don't see much, is pretty flat as supposed to be. Then of course over here in the red we see the spectrum of rhodium. So we see the peak over here, the K alpha, and then we see the K beta over here.